This lesson is about the effect of temperature on enzyme activity. So the title of today is Enzymes and Temperature. By the end of this lesson, we should be able to state the optimum temperature for the activity of digestive enzymes and describe how denaturing prevents enzymes from performing their function, using diagrams to help your description. So we should write our notes in the Cornell note-taking system with our objectives on the left, matched up with our notes answering those objectives on the right. Then we'll write a summary of what we've learned at the end of the lesson. So an enzyme is made up of two important parts: the main body of the enzyme and the active site. However, if an enzyme becomes denatured, the body and shape of the enzyme can change, preventing the active site from being able to be accessed by the substrate. That is, in this case, the molecule that's going to be broken down by that enzyme. So without enzymes, the rate of reaction depends on temperature. The greater the temperature, the quicker the reactions happen. So in reactions that happen without enzymes, the reaction rate always becomes quicker as temperature increases. However, the rate of reaction with enzymes is different. With enzymes, the temperature increases activity until the point at which denaturation causes the enzymes to change shape and therefore no longer work as effectively. As you can see here, these enzymes, their optimum temperature is approximately 37 degrees. If the temperature is too low, the activity rate is simply slow. But if the temperature gets too high, not only does the activity rate decrease, but the enzymes become denatured and cannot be restored. So let's look at the denaturation problem. Amylase, at various temperatures, will have a different ability to act on starch. So at very low temperatures, the amylase will move around slowly, because at slow temperatures molecules move slower, but it will still work because the active site will still be accessible to the starch substrate. At optimum temperatures, around 37 degrees, the enzyme will be moving more quickly, as will the starch, but it will also still be working. This is the optimum temperature because not only is the enzyme working, but it's colliding frequently with the starch molecules because the molecules are moving fast. However, if the temperature goes above the optimum temperature, the enzymes are moving around fast and colliding very frequently with the starch substrate, but because the enzymes are denatured, they are no longer able to break the starch down into the simpler sugars.